This is Noah Grabert. This is a Lab 2 assignment for the Energy Systems Lab. We were tasked to choose one of the highlight sections of the P&ID below and create a video that describes the functionality of the chosen section. For me, I chose the blue section on this right side, and the questions we had to answer were describe the overall functionality of the section. After analyzing the section, I found that a good overall statement of it is that this section cools, stores, and regulates coolant for the system, and the coolant is also used to cool the hydrogen that's used for the system. For this fuel cell stack is the main purpose of this blue section. So I'll be getting into question 2, describing the flows into and out of the components. I have a smaller picture of this actual section, so that way it's a little bit easier to see. We're going to start on this side. So right here, even though this is right outside the section, it's important because this is actually how hydrogen flows into this portion of the section. The only way that it can flow in is by this ball valve, which has a solenoid actuator. The solenoid actuator is automated use, so that means that it's gonna automatically turn on and off for the hydrogen to pass through. All right, so we'll go this way following this pipe, and the hydrogen can either go up or it can go down. We'll follow, it all depends on this also solenoid actuated ball valve. So let's say that this is closed, so the hydrogen will go up here. This right here, this is an ice catcher. With the hydrogen being so cold at this section, it can produce ice, and if there's ice or solids in the actual product that's flowing, then it's not going to flow very well. So this is going to catch all the ice, and then it's going to allow the hydrogen to go into this vessel that's holding hydrogen at a specific pressure and temperature. And this little section that's attached to the vessel, this is called a cryocooler. This is going to keep the vessel at a specific temperature and pressure, because the hydrogen needs to be readily accessible for the system to function correctly. And then attached to this vessel is 3 types of valves. Right here we have a gate valve with a manual handle. We have a relief valve, or pressure relief valve, and then we have a ball valve with another solenoid actuator. So the point of these valves is to kind of control the the pressure that's within this vessel right here. So let's say that it actually has many uses. So if the pressure is too high, then this pressure relief valve is going to allow excess hydrogen to flow out. If the workers want to manually release some either pressure, or you want to use the hydrogen for something else, they can release it with this gate valve. And so there's many uses to these valves. So we'll go back to this intersection right here. So if the ball valve right here is opened, then you have the hydrogen that flows to this portion right here, which is a forward pressure regulator, and this is used to maintain a minimum pressure level when heading downstream. If the pressure is too high of the hydrogen, it might be a little hard to handle, and so this is used to regulate it. And if this valve is closed, then the hydrogen is going to go into a heat exchanger. If this valve is open, which this is a relief valve again, if the pressure is too high, then it's going to vent out and lose the pressure, so that way it's able to handle properly. But whenever it's closed, it's going to go into this heat exchanger. All right, and within this heat exchanger, you're going to have two fluids into it. You're going to have hydrogen in, and then you're going to have coolant in from another section. So what's going to happen is this coolant is going to cool the hydrogen inside of this heat exchanger. And so this hydrogen is now going to be cold, going out into whatever other sections it needs, and then the coolant is going to come into this huge section right here. So this is all going to be coolant right here. All this section is hydrogen, and then all this is coolant. All right, so let's go to this section. We're going to cross over these lines. These lines are part of it, but not for this section right here. So you're going to go to this line, and you're going to follow it right here. So coolant also comes from this line, but that's not relevant for this blue section. All right, so we have coolant that will come through here and then into this radiator, which is going to cool the coolant after. Because since the coolant was used to cool the hydrogen right here, this radiator is going to cool it again, and then it's going to bring it into this coolant reservoir where it's going to store, and it's also going to keep the coolant kind of regulated and safe from anything else. From there, we also have another ball valve with a solenoid actuator. Once again, going to be electronically, automatically used if it wants to be open or closed. From this ball valve, we have a pump. So this pump is going to actually push the coolant through the pipes. It's going to transfer electrical energy to mechanical energy to actually push the flow of the fluid. And then right here is a turbine flow meter. So what's this going to do is it's going to measure the volumetric flow rate. And the reason for doing that is to make sure that we have a certain amount of power that's going into this pump to make the volumetric flow rate at a certain point. And so these two kind of work intertwined with each other. So through there, you have two ways that this coolant can split. It's either going to split and go back into the radiator after going through this section right here, which is a mass flow controller. This is going to regulate the amount of coolant going into the radiator. It's going to section off so that way it's not a bulk of coolant going into the radiator, then it could potentially hurt it. But it's either going to go through this mass flow controller or it's going to go this way. All right. And so when it goes this way, it can actually, once again, it'll split into two sections. It'll either go up it'll either go up or down. So if it goes down, it's going to go through another mass flow controller that's going to act the same way as this one. And the only way it'll go through the rest of this is if this solenoid actuated ball valve is opened. All right. And then if it doesn't go this way, then it'll go this way through another mass flow controller, and once again another solenoid actuated ball valve. So there's certain aspects, like say that if this ball valve is closed, then the coolant will only go this way. If this ball valve is closed, the coolant will only go this way. So there's different types of tweaks that the operator can use in order to control where the coolant and where the hydrogen is going in and out of the system. But yeah, that's your main purpose of where it's going in and out. Like I said, I described where it's automated, manual. Your automation is going to come from these solenoid actuated ball valves, because that a solenoid actuator is going to be like electrically activated, and so it can actually open or close depending on if a current break is done through it. And then you have your manual actuators, like this gate valve right here. That's manually actuated. Let's say this pressure relief valve, that's just going to automatically release pressure when it gets to a certain point. And then that's really the main ones. Everything else is going to work based off of those. And then, yeah, question 4. Like I said, using some overlapping, you have to know that hydrogen is coming through here. Hydrogen is leaving here to the rest of the system. Coolant is coming from another system into the heat exchanger, and then that's why you have coolant all over here. So yeah, summarize, this is your main hydrogen portion of it, and then it will get released. This is your main coolant portion, and that's going to be used to distribute coolant throughout the system and to also cool the hydrogen with this key heat exchanger right here. But yes, so that's it. So thank you.